Hi, this is Jason with Forney Industries. I'd like to introduce you to the Forney Easy Weld 140 MP. The MP stands for multi-process. This machine is capable of Mig welding, stick welding, and TIG welding. Particularly, this machine is fantastic for Mig welding and fantastic for stick welding. The TIG is okay as well, but the TIG functionality on this machine is really for more introduction and so forth. The TIG functionality is lift arc TIG only, and there is no high frequency start or pulse controls or anything like that, but it is fun to play around with TIG. But if you want a really good MIG welding machine and stick welding machine, this is a fantastic option. What I love about this machine is it operates off of a 120 volt machine, so I can use it in my garage without having special electrical requirements. The typical customer that buys this might be a do-it-yourselfer, whether they work on the farm, the ranch, they have their garage, maybe they have an automobile restoration project, or they need to fix their lawnmower, or they want to fix a broken trailer. This machine is designed for that. It welds fantastic from sheet metal up to a 1/4 inch. So this is an example of a 1/4 inch material. When you think about it, most DIYers rarely weld thicker than a 1/4 inch material. So this machine is well suited for your DIYer. Okay. It can primarily weld on steel. We do not recommend welding aluminum with it. Some customers try to convert this over to MIG weld aluminum, but it just does not have enough amperage for MIG welding aluminum. So I would recommend sticking with steel and stainless steel with this machine. Let's go back to the power requirements. We talk about this machine as a 120 volt machine. So if I look at the power cord, you can see this will plug into a 120 volt outlet like I have back here, and you'll find in your garage. At minimum, we recommend a 20 amp circuit breaker, and it's preferred if you use a 25 or 30 amp circuit breaker. Some of your electrical codes allow a dedicated circuit to use a 25 or 30 amp circuit breaker. Sometimes you need to increase the wire gauge size, and it usually needs to be a dedicated. What you don't want to have is you don't want to have lights and other things hooked up into the circuit that you're going to be welding with, because this machine needs every bit of the amperage that you can provide it from a 120 volt circuit. The output on this machine varies. It depends whether you're stick welding, TIG welding, or MIG welding. In general, you could say this outputs 100 amps, and that's correct on stick welding and TIG welding. It will produce more than 100 amps on MIG welding, and usually most of those amperages are rated at 30% duty cycle. However, that 30% duty cycle is really tested at least 110 degrees Fahrenheit, and I don't know too many people that weld at 110 degrees Fahrenheit. So your real world duty cycle is probably going to be more like 50 to 80%, meaning I can weld from 5 to 8 minutes before it might need to shut down and cool off for a couple minutes. So, and usually for the DIYer, I don't know too many DIYers that weld longer than 5 to 8 minutes, but we usually have no problem using this in a garage type environment for 5 to 8 minutes. Okay, this machine is generator friendly, just like all of our Forney Easy Weld machines. We recommend at least a 4,000 watt generator. A larger generator is better, and we need at least less than 5% total harmonic distortion, or 5% THD. I do not recommend using an extension cord. However, I do realize there are times when you need an extension cord. If you need an extension cord, don't use one longer than 25 foot, and it needs to be at least a 12 gauge extension cord. Okay, so let's get into how this machine operates. Let's focus first on stick welding, because stick welding with this machine is very simple and easy. Okay, so any of you that have been welding before know that when you're stick welding, you're going to use primarily electrode positive. So what do I mean by electrode positive? Well, I'm going to grab my electrode holder, which I have right here. Okay, grab this, I'm going to take my DINS connector and I'm going to put it into my positive terminal right here. Okay? You put it in there, you rotate it. Now my electrode holder is hooked into positive, so I'm running electrode positive. Okay? And then you'll notice that my ground clamp I have right here is hooked into my negative terminal. Okay? For most of welding, you're going to have your ground clamp hooked into your negative terminal. You're going to want to take your ground clamp and attach it to something that's on your welding table that's nice and clean. You don't want to attach this to a painted surface, a rusty surface, or something like that. You're just not going to get a good ground path. So make sure you're attaching your ground to something nice and clean. Okay? So I have electrode positive. I have my ground hooked to negative. Okay? This here, you might go, well, what am I supposed to do with this? This is your Mig welding jumper. Okay, we're going to talk a little bit more about this when we get into the Mig welding function. But at least for right now, I don't care about my polarity jumper. I don't care about my Mig torch. I can have my Mig torch attached when I'm stick welding. That's not a problem. So up here on the control panel, you're going to want to select stick welding, which happens to be the green one in the middle. Okay, and then you'll notice down below there's some color codes here. Okay. Green is for stick welding, and I adjust my amperage with this knob. You'll notice that there's nothing over here to adjust. This is the wire feed symbol over here. Again, that's for Mig welding. So on this side, I'm going to be able to adjust my amperage. You're basically going to adjust your amperage from about 20 amps on the low end all the way up to about 100 amps on the high end. Okay, and so if I'm stick welding, this machine is really good for some of your more common electrodes. For instance, I love using this machine with a 6011, 7018, 6013, 7014. 7014 happens to be my personal favorite and my go-to rod on this machine. One of the things some customers don't realize is that not all welding electrodes are created equal, meaning that if you grab a Forney welding electrode, it's going to operate on lower amperage than some of your other brands of electrodes in the market. And that's particularly helpful when you're running off of a 120 volt circuit. You want to have that rod run at lower amperage if at all possible. So one of the nice things about this machine is it actually puts out enough amperage so that I can run up to a 1/8 inch electrode. Now, it's not going to be easy to run a 1/8 inch electrode, especially if it's 7018. That's going to be a bit of a challenge. But 7014 or 6013 1/8, no problem. This machine will use it and produce very good welds with 1/8 electrodes. The most common diameter stick welding electrodes that you're going to use with this machine are your 3/32 diameters. And then if you need to weld on sheet metal, something really thin, I would grab a 5/64 diameter. Particularly the 6013 rod is really good for welding on sheet metal. Okay, so with stick welding, that's pretty much it. It's nice and simple, easy to do. Electrode positive. Now at this point, we're going to transition to Mig welding. I want to show you how simple it is to transition to Mig welding. Okay. All I need to do is take my stick welding electrode, okay? I'm going to remove it from my positive terminal, okay? I'm going to go ahead and set this off to the side. I'm going to grab this polarity jumper. Now this jumper here is for Mig welding, okay? I'm going to attach this polarity jumper to my positive terminal, okay? I'm going to leave my ground attached to my negative terminal. So I'm running Mig welding, electrode positive with my jumper, and my ground is attached to the negative. Okay, that's for standard Mig welding if I'm using gas. Now, if I'm using a flux core self-shielding wire, all right, I'm going to reverse this. I'm going to take this setup. Okay, I'm going to take my ground. Okay, ground's going to go to positive. All right, and I'm going to take my Mig jumper and go to negative. So most self-shield flux core Mig wires run on electrode negative. Okay, it's really that simple. it takes all of 15 seconds to change between stick welding and MIG welding, which is one of the things I love about this machine. So when you're adjusting your parameters on MIG welding, you'll again look at this control panel here. You'll select MIG welding, which is the top one, that's in red. You'll notice that down here in red you see a V for voltage. So I'm going to adjust my voltage with this knob here, and then I'm going to adjust my wire feed speed with this knob here in red. Okay, so very simple. A couple tips when I'm MIG welding. Normally I want to have my wire feed speed and my voltage roughly in the same position on these dials. Okay, if I have my voltage way over here and my wire feed speed cranked up, it's just not going to weld well. Okay, so that's just a quick visual indicator. Hey, these should be somewhere close to the same number. So if I'm running a 6 on voltage over here, I'm probably going to run about a 6 on wire feed speed over here. Now that's primarily for 030 MIG wire diameter. We strongly recommend using 030 flux core on this and 030 solid wire on this. Okay, some customers do like to use 023 solid, and I'm fine with that. If I'm welding on sheet metal, I will definitely select an 023 or 024 solid wire on this machine, but most of the time I'm going to be running 030 diameter, even if you're doing flux core welding. Some customers really want to run a 035 diameter. First of all, this will not run a 035 solid. There's just not enough amperage for 035 solid. It can run an 035 flux core. You just aren't going to get very good welding results out of it. You just don't have enough amperage to really push that 035 flux core wire. So again, please, you'd be a lot happier using an 030 MIG wire in this. You have a nice weight range, sweet spot, really easy to dial it in. Okay. So let's go ahead and we're going to take a look on the inside of this cabinet for the setup guide. Okay. All right, so we lift up the hood here. You'll notice we have a setup chart here. You'll have parameters in here for stick welding and for MIG welding, primarily using some of your more common diameters. You'll notice here that we have a solid MIG wire, 030 diameter. The wire comes off of the spool and comes off the bottom. We call this a bottom feeder. It goes through this inlet guide here into your wire drive system and then through your torch. Okay, so it's really important that you have your tensions set properly on this machine. Okay, so how do I know if my tension is set properly on this machine? First of all, you want to make sure that your wing nut here is not really cranked down. Normally my wing nut, the end of my wing nut is about even with the end of this bolt here, and that's a good rule of thumb for adjusting my despooling tension here. Also, when I'm done welding, I want my wire coming off of my spool to sag a little bit and to easily move. If that wire is coming off really tight, that means I have too much tension back here on my spool, and I need to reduce the tension on my wing nut a little bit. Okay, so how do I know if I have the right tension set on my tension arm here for my wire feeder? Well, a good rule of thumb is 2. If you're cranking this down all the way to 3, odds are you're going to start deforming your wire, and that's not a good thing. Especially with flux core wires, you have a tubular wire, and if you put too much tension on this here, you're going to end up squashing that flux core wire, and that's not going to help you feed wire all the way through your torch. So again, I'd back this off. Typically I'm in that 2 range, maybe 2.5 max, and that's a good rule of thumb for this machine. Okay, and then if you want, you can always flip this down. This on your idler flips up. You can always change out your drive roll here. You'll notice on your drive roll, you have 2 grooves. You have one for flux core and one for solid. Okay, all right. So if you look on your grooves, what you'll see is a groove that has, you can actually put your fingernail in it. You'll actually feel it's knurled, and that knurled groove is for your flux core wires. And then you'll have another groove that is smooth, or it's called a V groove. Okay, that V groove is for your solid wires. So the knurled or the rough groove is for your flux core wires. Your smooth V groove is for your solid wires. So I want to make sure my solid wire is going into my V groove. So I'll put this back on here. Okay, there we go. Oh, yeah, would you look at that? I put it in backwards. All right, so I'm just going to flip it here. Flip this over. Okay, now I look at it. Yep, sure enough, my solid wire is in my V groove. We're going to put this back on. Okay, flip down my arm. There you go. My setting here is probably about 2. Okay, that looks good, looks good, looks good. Let's talk a little bit about the consumables on this torch. Okay. This uses a very standard, common consumables on the market here. This happens to be your nozzle. You can simply grab it and remove it. Okay. All right. And then here we have a diffuser. It's a brass diffuser. You'll notice a couple holes in it. This is where your shielding gas comes out of. Okay, and then you have a tip here. You want to make sure your tip is nice and snug in here. If it's not snug, this one happened to be a little bit loose, I would take my welding pliers, in this case like this. I would just snug that down a little bit so it's not loose, because if that's loose, you're not going to get good conductivity through your welding wire. And then you can snip off this. Normally, when you're welding, you're going to want about a 1/2 inch stick out between the end of the tip and whatever you're welding on. I don't recommend any longer than a 3/4 inch stick out, but typically I'm welding with about a 1/2 inch stick out. That's, again, the distance between my tip and my workpiece. Okay, I want to make sure that I don't have a spatter in the holes of my diffuser, because I want to make sure I have good shielding gas coverage. Once in a while I'll see customers that has spatter baked in here. The other thing I look at is I look at my nozzle. Okay, I don't want a bunch of spatter in my nozzle, because again, that's going to create shielding gas problems. So my diffuser looks like it's in pretty good shape. My nozzle, well, it has a little bit of spatter in there. It's okay. So everything looks good there. All right. If I'm going to be doing MIG welding, all right, I want to make sure I have my polarity set right, which it's not. We changed it over for flux core, so we're going to quickly change it back to solid wire. Okay, I'm going to put my ground and my negative. Okay, I'm going to put my MIG jumper, which is attached to my wire feeder, in here. So wire is electrode positive. Okay, I am now set up for solid MIG welding. Okay, I want to take my gas connection that comes off of my regulator. This is a simple common gas connection. Goes into the back of the welding machine here. Attach that. Okay. Use a small crescent wrench or an adjustable wrench to go ahead and tighten that up. Okay, it's now tight. I'm going to take my power, power cord, plug it in. Okay, I'm going to turn it on. I hear the fan kick on. When the fan kicks on, that says, hey, it's good. I'm going to just take a quick peek here. I've got a green light on my input voltage. Hey, that looks good. I don't have any error lights. Everything is good. I have my settings here. I can refer to my setup chart on again on my panel here. Make sure my settings here are good. Now that I'm set up, I can go ahead and get to welding. So when I'm welding, there are a few things that I would want to accompany my welding machine. Okay, one of the most important tools I need is a pair of welding pliers. These welding pliers allow me to clean out the slag in my tip or the spatter in my tip. I can cut the wire. I can remove my tip with this and remove my hot nozzle with this. So there's multiple functions with a pair of welding pliers. So welding pliers are key. I always have a wire brush because sometimes I need to prep the surface. I have a slag hammer, especially if I'm stick welding. A slag hammer is critical. And then I have a welding helmet. Personally, I prefer an auto darkening welding helmet so that I can see what I'm working on. And then as soon as I strike the arc, the lens darkens. And it's much easier, particularly for people new to welding, to use an auto darkening helmet. And then you always want to use safety glasses when you're actually welding, because particularly if you're stick welding, the slag and the spatter can come up and get in your eye, even over your welding helmet. So always use safety glasses. And then I like a pair of thin welding gloves. I don't like particularly the very thick welding gloves. I like something a little bit on the thin side so I have good dexterity and I can feel what I'm working on. So these are some of the things that you'll need along with a welding machine to get started. Okay, and that concludes using the Forney Easy Weld 140 MP. We didn't really touch on TIG welding today. TIG welding is definitely possible, and that would be a complete separate deal. If you have questions on how to use this machine or to TIG weld, I would definitely recommend that you call into Forney, ask to speak with one of our engineering service technicians. We can walk you through the setup on this machine, troubleshooting. If you have application questions or you want to know how to TIG weld, we can walk you through all of that, and we'd be happy to help you.